Welcome to a lesson with Dr. Powell. Let's take a look at an example of a proof where we're definition matching. That means we want to show perhaps that something meets the criteria um, that's required to be within maybe a set or have a certain um, characterization associated with it. In this particular case, we would like to show that numbers of this form right here are in the set B. The set B consists of all integers um, where if the integer is even, it's greater than 11, and if it's odd, it's less than -10. Okay, so we have this right here, and we want to show that expressions of this form, where n is any integer greater than 20, actually happen to land in that set. Now, perhaps we could pause for a minute and think about what this set looks like, the set B. Um, so it's even numbers greater than 11. So that would be like 12, 14, 16, and so forth. And odd numbers less than -10. So like -11, -13, and so forth. So intuitively, we can kind of think about what this is, but we have some criteria that define what this whole set is and what it means to be in the set. So what we're going to do is we're going to try to look at this right here and match it to these characterizations to show that anything of this type is actually in this set B. Now, notice that what changes as we look at this for any integer n is greater than 20, we're looking at positives or negatives. And so it makes sense to think of cases when n is even or odd, because that'll affect whether this is negative or positive here. It may affect things up here as well. So suppose, for instance, let's take the case when n is even. Now, what happens when n is even? Let's just look at what happens in that case. Notice how the cases that we choose, n is even and odd, cover all cases, because every number, every integer, that is either even or odd. Okay, so in the case when n is even, this expression simplifies to n minus 2. And noticing that n is greater than 20, n minus 2 is definitely greater than 11. So we check off this box right here, greater than 11. Well, what about this expression? Is it even? Can we check off that box? And yes. And that's because n is even, and if you take 2 out away from an even number, you still have an even number. It's like you can factor a 2 out of this and out of this guy right here, if you'd like. And notice that 2 is a factor of n minus 2 if it's a factor of n. Okay, great. So we covered this case when n is even. Now let's look at the case when n is odd. When n is odd, this becomes a negative. So just negative n minus 2. Now, n is greater than 20. And so if we didn't have these negatives, the inequality like n greater than 20 would be going this way, but with these negatives, it's the opposite. And so we think negative n minus 2 is going to be less than negative quantity 20 minus 2. So it's going to be less than negative 18, which is definitely less than negative 10. Check off that box. What about the box of being odd? Well, notice that n is even, and if you take n is odd, and if you take an even number, if you add an even number to or subtract an even number to an odd number, you end up getting something odd yet again. An even number away from an odd is an odd, which means this is definitely an odd, so we can check off that box. So we've checked off both of those boxes, which shows that in this case, we are definitely we are in B, and in this case, we're in B. So in all cases, we're in B, and we've just checked off the boxes in each case, and therefore we have shown that numbers of this type truly live in this set right here. Thanks for watching.